All right, this is section 8.4, rational expressions. First thing we're going to do is simplify some fractions, then we're going to multiply and divide fractions. To simplify fractions, we're going to look at this as a algebra student instead of a elementary school student. So you might say, hey, I could divide each of these by 3, but we're going to factor and then cancel out like factors. That's how we're going to look at this. So we're going to think about 12 as 2 times 2 times 3, and we're going to think about 15 as 3 times 5. So that's the prime factorization of 12 and the prime factorization of 15. Then we say to ourselves, hey, 3 divided by 3 in the opposite sides of the fraction line here, so it's multiplying on the top, dividing on the bottom, so these cancel each other out. They become 1. So what am I left with? 2 times 2, which is 4 over 5. So it's 4/5. So 12 out of 15 is the same ratio as 4 out of 5. We can do the same thing with b here. Simplify this fraction. 3 times x is factored. 9 is 3 times 3, and x is x times x. So we can cross out the like factors here above and below the fraction line. So that would go away, boom, go away. Technically it goes away because the same thing divided by the same thing is 1. 1 times x is just x. 3 divided by 3 is 1. 1 times 3 is 1. So it gets absorbed. But there's also a 1 left over on the top, right? There's a multiplication of 1 that you don't necessarily there. Or you could say that this 1 times 1 is that 1 there. However you think about it, there's a 1 left on the top, and there's a 3x left on the bottom. Okay, now, when it looks like this, we can still do the same thing. We can't hack this way. We have to cancel out like factors. So the first step is to factor. So 2 sets of parentheses, put in x in each. So we're going to make this 2 and 3, so plus 2 and plus 3. 2 and 3 make 6 by multiplication, and 2 and 3 added together makes the 5. And then negative 8 and positive 2. That would make the negative 6 in the middle, and there's a minus in the back. The signs are opposite, so negative 8 plus 2 cancels out, and we get x minus 8 over x plus 3. And that's the answer. Whoops, ran off the screen there. So these cancel out. That divided by that doesn't really divide, so you leave it as a fraction. Hence the name of the section, rational expressions. That's a rational expression. Not an equation, just an expression. Okay, next we're going to multiply. You do numerator times numerator, denominator times denominator. But I don't want to multiply this all together until I simplify it. And so I'm going to factor it and cancel out like factors. So the numerator here is 3x and x. X minus 5 is already factored. This one here is the difference of two perfect squares. So it's going to factor into x minus 5 and x plus 5 over 3x and x. And let's see, 2 and 1. Oh, the 2 needs to be opposite of the 3 because this makes negative, that would make negative 6, and then negative 1 more would make negative 7. And then up here, I need the 2 to be opposite the 3, so it's going to be 6. That 6x needs to be positive, minus 1 right there. So let's see, what cancels out? The minus 5s cancel out, and the 3x minus 1s cancel out. So I'm left with these two, numerator times numerator, denominator, this is just by itself there. So I'm going to FOIL this out. X times x is equal to x squared. X times the 5 is 5x. 2 times the x is 2x. 5x and 2x makes 7x. And then, whoops, 2 times 5 makes 10. Over x minus 2. All right. Divide. Dividing fractions. We don't do it. We don't divide fractions. We change this. We do the inverse of this fraction. So the inverse of a fraction flips the fraction upside down. If you do the inverse of this fraction, guess what? You get to do the inverse of that symbol right there. So we're going to change this to multiplication. So it's x plus 2x minus 15 over x squared minus 16 times 3x minus 12 over x plus 1. So you flip over the second fraction. Then we start factoring just like we did before. there's a common factor of 3 right there, so I take that out. All right, so here we go. This is the difference of two perfect squares, minus 4 plus 4. This would be x minus 4. That would make the 12 and the 3x. And then up here we have x and x, positive 5 minus 3. That makes a negative 2 in the middle. Okay, so I can't get rid of as much stuff here. Get rid of these. Now, this is the same thing as that up there, so I don't really need to multiply it back together because it's sitting right here, and I'm going to multiply it by 3. So it's the top times the 3. So because you're doing this times this, so it's really this times that. So I'm going to distribute the 3 through. So it's 3 times each one of those, so triple the x, that's squared. So it's 3x squared plus 6x minus 45. So I did 3 times this, 3 times this, 3 times that, over, then I'm going to FOIL the numerator out. So it's x squared, x, and 4x makes 5x, and then plus 4. All right. Now I'm going to do a bunch of problems on a worksheet to demonstrate more of this. All right, so this would be going right along with the examples. It says simplify, state any restrictions on the variable. Basically what that means is you can't divide by 0. So what x's cause division of 0? So here we go. 2x squared. Factor out a 2x here. And we're left with 2x minus 1. 2x times 2x would be 4x squared. 2x times the 1 makes that. Now, this here, when does that equal 0? Well, x equals 0 would make that 0. And then what makes this 0 would be a half. Because if you add 1 divided by 2, x equals 1/2. So those are the two restrictions. X cannot be 0 and x cannot be a half. The two restrictions on the variable. And then these cancel out. There's a 1 left on top, so the answer is 1 over 2x minus 1 with those restrictions. Next problem, the restriction here is 1 because 1 minus 1 would make 0, so b cannot be 1. We factor the top, b plus 1, b minus 1, over b minus 1. That cancels out. What's left? b plus 1 with a restriction of b minus 1. Or b equals, cannot equal 1, sorry. Okay, now I'm going to go down here, take a 2 out, x plus 5, factor x and x plus 5 plus 5. Alright, so x cannot be negative 5, because negative 5 plus 5 would be 0, and you'd be dividing by 0, so that's bad, you can't do that. These cancels out, they're 2 over x plus 5. So there's the restrictions, there's the problem. Okay, 3 more. We're going to multiply. Any restrictions? Well, y cannot be 0 because you'd be dividing by 0, and x cannot be 0 as well. Now we're going to factor this all out just like I did on example, well, kind of like example, kind of like this example right here. Where you like factor everything out and cancel stuff.
Mr. White, please call extension.
Alright, and back. So it's 2 times 2 times x, that's the top there. 5y is already factored. 7y is already factored. And 2 times 2 times 3 times x times x times x times x would be x to the 4th. Now we start hacking stuff away. The 2's hack away, boom, boom, gone. Y is gone. X, 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 x. So there's 2 x's left, there's a 3 left, and there's a 5 left on the bottom. Because the 2 x's here went out with those 2 x's there. The 2 2's go with the 2 2's, no ballet intended. And 7 is on the top, that's the only thing left. 5 times 3 is 15x squared. Alright, with that being the restrictions. The restrictions here would be, well, let's factor it first and you can see the restrictions a lot easier. So there's a 4 in common on the numerator here, a 5 in common here. A 5 in common here, and a 3 in common there. So we take those out. So what are we left with? 2y minus 1, 2y minus 1, because that makes 10 and 5. And then here I get y minus 3 and y minus 3. Hey, lots of stuff goes out. So boom, 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 boom. 4/3. Okay, the restrictions, you can't have 3 because 3 minus 3, so y cannot be 3 because 3 minus 3 would be 0. And then a half again, a half times 2, yep, so y cannot be 1/2. Okay, more factoring. Parenthesis, 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 over, parenthesis, 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 times x plus 1. Can't factor that. Take an x out of this. So it's x plus 2. X minus 2, x plus 2, x minus 1, x plus 1. So it's the difference of two perfect squares twice. Now we start hacking stuff away. Hack, hack. Oh, let's do the restrictions before I finish hacking. So 1, x cannot be 1, negative 1, or 0 or negative 2. Because if you put 0 there, that would cause a division of 0. Negative 2 plus 2 would be 0. 1, negative 1, 1 minus 1, 0, negative 1 plus 1, 0. So we hack, we hack, we hack, we hack, and we're left with 2 on the top, and then it's x, and that's left, so x times x is x squared, and minus x. All right, now the division page. We really don't do the division page, we just turn it into a multiplication page. So it's 7 times x, 2 times 2 times y times y times y, and then I'm going to flip it over, times 8 is 2 times 2 times 2 times y, over 21, which is 3 times 7 times x cubed, x times x times x. So I flipped and factored at the same time. Fantastic. Okay, now with the division ones, you have to actually list the restrictions here, here, and there. That was a fantastic sneeze. I do all my videos in one take, so if a sneeze happens, it happens. No editing required. Okay, so what's weird about the division ones, if this here is 0, then you'd be dividing 0 into this fraction. So this can't be 0 here, this can't be 0 here, and that can't be 0 there. The only thing that could be 0 is this one numerator right here. So none of those could be equal to 0. So x cannot be 0, and then it can't be 0 there, so y cannot be 0, and it can't be 0 there, so y cannot be 0 again. So you have to consider 0 in 3 places for the division ones, which is kind of weird. Okay, now we start hacking. 7, 7, x, x, 2 2's, 2 2's. So 2y is, nope. Oh, y and y. So the only thing that's left on the top is a 2. Gone, gone. We have a y squared. We have an x squared. And it looks like a 3. So the 3 is left over. Y squared and x squared. Yeah, those are there still. Yep, that's right. And then that's the restrictions. All right, flip and factor at the same time. 6. X minus y, and flip. I'm going to cheat a little bit here. I'm going to say 18 is 6 times 3 because I know that that's going to cancel out. It's not factored to 100%. And then 5 is x minus y. Okay, well what will make this 0 is if x equals y. So if it's 5 and 5, then you get 0. And this is x plus y. So if x equals y, that would be a restriction. Because if you had 4 minus 4, you get 0. And then you can't have 0 there either, because it'd be 0 on the bottom. And then that's never 0, so we're okay with that one. All right, so we hack, we hack, we hack, we hack. We're left with 5 times x plus y over 3. And you could distribute that through and say, call it 5x plus 5y. And then there's the restrictions. You can't have x equal to y. And then the last one, we're going to factor and flip at the same time. So we get x times x for x squared. Then this factors into x plus 1, So that would be that, and then I'm going to flip it. That's the difference of two perfect squares, so that's x plus 1 and x minus 1 over 3x. So gone, 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 gone. We're left with x on the top, x minus 1 on the top, and then 3, and then x plus 1 on the bottom. So we got to go back to the original. So x cannot be negative 1 for sure, because negative 1 plus 1 would be 0. And then here x cannot be 1. Oh, and up here I should have put cannot be y. Whoops, this one right there, cannot be y. So we hacked down an x, there's an x left over here, there's that left over, 3 is left over, that got hacked away, so this is the kind of the answer. But remember, x cannot be plus or minus 1 because that would cause division of 0. Oh, there's an x right there, so x cannot be 0 as well. So it can't be 0 because that would make this whole thing 0, which would be dividing by 0. That plus or minus 1, and that right there. So 3, you have to check 3 parts for 0 on this because this can't be 0, making the whole division of 0. And x squared minus x over 3x plus 3. And then it's equal to, or that's the restrictions on the domain.